Good morning, friends. We have seen some topics in rotational dynamics in last two lectures. In that two lectures, we see the characteristics of circular motion, kinematics and dynamics of circular motion, applications of circular motions. That's our motion of a vehicle along curved horizontal road. Second application is motion of a vehicle in well of death. Third application is motion of a vehicle on curved banked road and conical pendulum. Now, today I am going to explain about the vertical circular motion. In our daily life or in practice, we observe two types of vertical circular motion. One is a vertical circular motion which is controlled by manually or by using machinery, but not controlled by the gravity. Another vertical circular motion which is controlled, fully controlled by gravitational force only, not controlled by the human beings, but controlled by the gravitational force or gravity. These are the two types. In the pictures here, the giant wheel, this is the giant wheel. Giant wheel rotates about the axis. This will be revolves in a vertical circular motions about this axis that can be controlled by the machinery attached to the system, to the wheel, or in small giant wheel that can be controlled by using manually by the persons. We observed that it. Another vertical circular motion is shown in these diagrams. In these diagrams, bucket contains the water that can be tied with this string and whirled in a vertical circular motions about the other end. About the other end. When we provide some kinetic energy at the lowest point in such a way that it can be revolves in a vertical circular motion. During this motion, the kinetic energy provided at the lowest points is interconverts into potential energy. Kinetic energy decreases and potential energy increases up to the highest point or top points of this vertical circular motion. At the top point, total kinetic energy becomes loss and it converts into potential energy. Again, if the bucket moves down from top points to the lowest points, in that case, the potential energy can be converted into kinetic energy. At the lowest positions, the total potential energy can be converted into totally kinetic energy. When the bucket reaches at the top points, at that time, the water cannot falls down. That water cannot, why cannot falls down? It can be observed by using the video. I start this video, see it, and then after that, I explain why the water in the bucket cannot fall down even though it attains the top points. Here, the at the lowest positions, that person provides the energy, kinetic energy, and due to that kinetic energy, the bucket containing water moves in a vertical circular motion. Now observe it again. Here, the bucket, that man bucket take directly topwards. At that time, water can be falls down. See that. In that case, why the water falls down? Since there is no vertical circular motion. Here, the force, gravitation, due to that gravitational force, water falls down. But in a circular motion, in the vertical circular motion, the forces acting on the bucket as well as the water have the same force, that is the centripetal force. And that centripetal force is provided by the gravitational force. Gravitational force here. And due to that, the water cannot fall down since the accelerations are the same here. Centripetal accelerations and the weight can be balances here, and due to the centrifugal force, the water cannot fall down in a vertical circular motions. That is one of the cause the water cannot fall down. But there will be another also cause. That cause can be shown also here. See that video full here. Here, that person says that whenever the bucket reaches at the top points, at that time the horizontal velocity is, if this horizontal velocity is greater than the critical velocity, at that time the water is stay in the bucket since its projectile motions is away from the circle, away from the circle. So the water cannot falls down. Water cannot falls down when this is the the speed having greater than the critical speed, greater than critical speed or equal to critical speed. But if the bucket containing waters have the speed less than critical speed, slowly at that time what will happen? See, observe that in the second case here, when the water containing buckets moves slowly than this critical speed, at that time path of the water is like this. In this case, the water falls down, falls down. That means when the water containing in the buckets have the critical velocity, that is the velocity required for the circular motions, are greater than 8, at that time water stay in the bucket, water stay in the bucket due to the centrifugal force, due to the centrifugal force acts on the water or experienced by the water. Also due to the inertia that can be stay in the buckets, that can be stay in the bucket. These are the two causes of the water stay in the buckets that can be seen here. Now we study the vertical circular motions which is fully controlled by the gravity in next two examples. Another example is when the mass is tied to a one end of the string and it can be whirled in a vertical circular motion. That means mass tied to a string. Let us assume that that mass is the point mass, heavy point mass. Here in the figures we show the point mass is suspended by or tied to one end of the string of length r, of length r. A heavy point mass of mass m attached to one end of the string of flexible, weightless and inextensible string of length r and whirled in a vertical circular motions, in a vertical circular motions under the gravity, under the gravity. So for this purpose we must provide the horizontal velocity at this lowest positions. If this vertical circular motion is anti-clockwise sense, anti-clockwise sense, at that time the horizontal velocity provided along these directions. If this horizontal velocity is in such a way that it completes vertical circular motion, so we assume that V will be the minimum speed at this lowest positions, at this lowest position, so it performs vertical circular motion. Vm be the speed at the m positions, that is horizontal positions. Vh be the velocity at the highest positions, and Vn be the velocity at the horizontal positions. The horizontal positions m and n at the same level, so the speed are same at both the cases. See that letter. And at any instance, if the particles moves from point L to point P in time interval t, at that time We assume that Vp be the speed at these P points and the height when the particles moves from L to P. At that time height is equal to L into D, that can be represented by H. This is H. To explain these concepts, first draw the diagrams and then give its explanations. Consider a spherical body of mass m attached to one end of the flexible, weightless and extensible string of length r and whirled in a vertical circular motion under gravity. That is first point of explanations. Second point, let VL be the velocity at lowest positions, L, Vp be the low velocity at point P, H be the height of a point P above the lowest positions, L, and theta be the angular displacement when the particles moves from point L to P. At that time angular displacement is theta. Is theta. Now at any positions P, the forces acting on, second point, so remember that forces acts on the body. The forces acting at any point P on the particles are its weight. Its weight. First is tension produced in a string, that is T0 or TP, that can be considered TP here. This is the tension TP. And another force is mg. Tension produced in a string along the string toward the center, that is toward the center, and its weight acting vertically downward direction. This weight can be resolved into two rectangular components. One is mg cos theta, which is along the string and away from the center, away from the center. And another is mg sin theta, mg sin theta, which is tangentially and comes toward the lowest positions. Due to that, the particles comes toward the lowest position or opposes to the motion, vertical circular motions la oppose karta. So that due to this tangential force, the speed becomes increases. Speed becomes decreases. Speed decreases when it goes from lowest position to highest position. But when it comes from highest position to lowest positions, at that time speed becomes increases due to this tangential force against. Due to this tangential force, the speed becomes increases. Speed becomes increases. Remember this thing. Now the velocity at any point P, the velocity at any point P, to find the expressions for velocity at any point. For that purpose, energy at lowest positions and energy at any positions are remain same according to the law of conservation of energy. According to law of conservation of energy, or we also express in change in kinetic energy is equal to change in potential energy. By using these equations is also we can find out that relations. But here I explain the according to the law of conservation of energy, energy at the any point is exactly equal to energy at lowest points. Energy at point P have the kinetic energy as well as potential energy, and that is equal to kinetic energy is equal to half mvp square plus potential energy mgh. This is the energy at point P. Now the energy at lowest positions is, if here is the speed at lowest position, then its kinetic energy is equal to half mvl square. This is the kinetic energy. And potential energy at the lowest positions, we have considered this is the ground level. This is the ground level. So the potential energy becomes zero. We have considered potential energy becomes zero. So the total energy at lowest point is half mvl square. Now from these equations, if we multiply by 2 and divide by m to these equations, we get Vp square plus 2 times Gh is equal to VL square. And from these equations, Vp square is equal to VL square minus 2 times Gh. This is from these equations, we can find out the velocity at any point P. Vp is equal to square root of VL square minus 2 times Gh. This is the expression for the speed of the particles in a vertical circular motion. In a vertical circular motion. In a vertical circular motion. Remember. Now, also from this equation, these equations, we can find out the relation between the velocities at lowest positions and at any position. This is the lowest positions and this is any position here. From this equation first, VL square is equal, VL square minus Vp square is equal to 2 times Gs. This is the relation between the square of the velocities at the two position, that is lowest position at any position. Now, if we find out the relation between the velocities at the lowest position and at this highest position, when the particle moves from the lowest position to the highest positions, at that time the becomes height becomes the equal to the diameter of this vertical circular motion, and that is equal to h is equal to twice r. H is equal to twice r, and instead of point P, we consider the highest point. Therefore, speed at the highest point is Vh. That means replace Vp as equal to Vh and h is equal to twice r in these equations. In above equations, we get VL square minus VH square is equal to 2 times G into 2 times R is equal to 4 times GR. This is the relation between the square of velocities at the lowest position and highest position. Remember these equations. That equation is most important for the next articles. Another expressions. That expressions is the tension at any point. Tension at any point. The necessary centripetal force at point P is, at point P, the centripetal force means the force towards the center. Here, the tension produced in the string is Tp, and mg cos theta is the components of weight of particles or weight of the body. These two, mg cos theta and Tp, are opposite to each others. Therefore, the net force toward the center is Tp minus mg cos theta. Tp minus mg cos theta. That provides the necessary centripetal force. Therefore, the centripetal force at the point P is mvp square upon r, where Vp is the speed at the positions P. Therefore, mvp square upon r is the centripetal force, and that can be provided by using Tp minus mg cos theta, where Tp is the tension produced in the string. So, the Tp is equal to, that means tension at point P is equal to, tension at point P is equal to mvp square upon r plus mg cos theta. This is the expression for the tension. But from right angle triangle ODP, ODP, OP is equal to R. So OL is also equal to R, but LD is equal to H. Therefore, OD is equal to R minus H from these triangles, and from these triangles, cos theta is equal to side OD upon hypotenuse OP, but OD is equal to R minus H and hypotenuse is equal to R. Therefore, cos theta is equal to R minus H upon R. Therefore, TP is equal to MVP square upon R plus mg into bracket R minus H upon R. Therefore, TP is equal to m upon R into bracket Vp square plus Gr minus Gh. This is the expression for the tension at any point. These expressions, tension at any point and velocity at any point, these expressions are not explained in your textbook. I have been explained only for the CAT examinations, NEET examinations. For that purpose, I can explain these concepts. Remember this. Now, from this, we can find out the tension at lowest positions, at horizontal positions, and at highest position H. Also, to find out the velocity or speed of the particles at lowest positions, at horizontal positions, and at highest positions. That how can we find out? See the next slides. In next slides, the point mass tied to a string and undergoes going a vertical circular motion under the gravity. At that time, we assume there are three different positions. One is the lowest positions, another is highest positions, and another is horizontal positions, that is M or N. Here we already find out the tension at any position. TP is equal to M upon R into bracket Vp square plus Gr minus Gh. From these expressions, when the particles reaches to the highest positions, at that time Vp is equal to Vh. Velocity can be changed. Say that velocity is Vp. When it reaches at highest point, it is equal to Vh, and the height h is equal to twice R. Substitute the value of Vp as Vh and h is equal to twice R in this equation. We get Th is equal to M upon R. Instead of Vp square, we write Vh square plus Gr minus G into twice R, that is minus twice Gr, and plus Gr, that is minus Gr here, and that is equal to mvh square upon R minus mg. This is the tension at the highest point. Similarly, the tension at the lowest point, at lowest positions, Vp is equal to Vl, that is the velocity at the lowest position we have in Vl, and h is equal to 0. Substitute these values in these equations. Tension at any point P, therefore tension at lowest positions is equal to M upon R. Instead of Vp square, we write Vl square plus Gr, h is equal to 0, so that's third term is 0. Therefore, the tension at the lowest point is equal to mvl square upon R plus mg. This is the tension at the lowest position. Similarly, tension at horizontal point, that is M or N. In both the cases, in both the positions, the speeds are remain same. Vp is equal to Vm or Vn. Vm and Vn are same since the positions are same. And h is equal to R. Therefore, tension at horizontal positions is equal to mvm square upon R Since H is equal to R, GR minus GR, that is 0. Therefore, here only the centripetal force will be acts on it. Tension provides the centripetal force in the horizontal position. In the horizontal position. These are the expression for the tension. Now, find out the velocity, minimum speed. What are the minimum speed at the lowest positions, at the highest position, and at the middle positions required to complete the vertical circular motion? To complete vertical circular motion. For that purpose, here the mass tied to a string. When this mass revolves in a vertical circular motions, if the tension becomes zero, when it goes from lowest position to the highest position, lowest to highest positions. In that case, if the tension becomes zero before reaching the highest positions, at that time it lose the vertical circular motions, that cannot perform the vertical circular motion. But when the tension cannot become zero, at that time it performs vertical circular motion. At that time it performs vertical circular motion. Then the conditions for complete the vertical circular motion, the tension at the highest points becomes zero or greater than zero. This is the conditions to complete vertical circular motions. Therefore, here we give at highest point H for looping the loop, that is to complete one's round of vertical circular path, tension at highest position is always equal to 0 or greater than 0. Always equal to 0 or greater than 0. Therefore, replace tension as m upon r into bracket Vh square minus gr is always greater than or equal to 0. M, that is the mass of the particles, and radius of vertical circular motion cannot be 0. Therefore, only the bracket Vh square minus gr is equal to 0. Vh square minus gr is equal to 0 or greater than 0. Therefore, from these expressions, Vh square is equal to or greater than gr, and therefore Vh is equal to or greater than square root of gr. That means to complete the vertical circular motions, the velocity or the speed at the highest point is equal to square root of gr or it. Greater than it. त्याच्यापेक्षा स्क्वेअर रूट ऑफ जी आर एवढं किंवा जी आर स्क्वेअर रूट ऑफ जी आर पेक्षा जास्त स्पीड पाहिजे. मग मिनिमम व्हेलॉसिटी किती ॲट हायेस्ट पॉइंट? द मिनिमम व्हेलॉसिटी ॲट हायेस्ट पॉइंट फॉर लूपिंग द लूप or to complete the vertical circular motion is Vh is equal to square root of gr. This is the minimum velocity required at the highest point. At the highest. Now, what is the minimum velocity required at the lowest positions? That can be found out by using these equations we have already studied in earlier slides. That is VL square minus VP square is equal to 2 times GH, and VL square minus VH square is equal to 4 times GR. This is already seen in the earlier slides. That is therefore the minimum velocity at lowest point for looping the loop is VL square is equal to, instead of VH square, we write square root of GR, that is GR here. That means VL square minus GR is equal to 4 times GR, and so by solve it, VL square is equal to 4 times GR plus GR, that is equal to 5 GR, and therefore VL is equal to square root of 5 times GR. This is the expression for the minimum velocity required at the lowest position that can be found out by using these equations and the equation from the expression for the velocity at the highest point. Similarly, the velocity at the horizontal positions Vp is equal to, that can be found out by using this equation. So Vp is equal to VL square minus 2 times GH. But instead of P points, we write the horizontal positions Vp. Substitute the value of VL as square root of 5 GR. By using this equations, Vm is equal to square root of 5 times GR minus 2 times G into H. Value of H is R in this case. Therefore, that is equal to square root of 5 times GR minus 2 times GR, that is equal to square root of 3 times GR. This is the speed at the horizontal positions M or N. M or N. These are the velocities at the highest positions, lowest positions, and at the horizontal positions in a vertical circummotion. Also, we can find out the expression for the kinetic energy, potential energy, and total energy of the body in a vertical circular motion. Kinetic energy is equal to, at any position, that is equal to half mvp square. Potential energy is equal to mgh, and total energy is equal to kinetic energy plus potential energy. From these expressions, we can find out the kinetic energy, potential energy, and total energy at the highest positions, lowest position, and at the horizontal positions M and N. Here, highest positions kinetic energy. Kinetic energy at highest positions is equal to half mvh square, and that is equal to, substitute the value of vh here, we get half m into gr, and that kinetic energy is equal to half mgr at the highest position. At the highest position, potential energy is equal to mgh. Here h is equal to twice r, h is equal to twice r. Therefore, the potential energy is equal to 2 times mgr. 2 times mgr. And total energy is equal to sum of this half mgr plus 2 mgr. 2 is LCM. Therefore, 1 plus 4 mgr, that is 5 mgr. That means 5 by 2 mgr. This is the total energy at the highest position. Similarly, we can find out the kinetic energy, potential energy, total energy at the lowest positions and at the horizontal positions M and N. That's our kinetic energy at lowest positions, VL square, half mVL square, that is equal to half m into VL square is 5 times GR. Substitute it here, we get kinetic energy at lowest position is equal to 5 by 2 times mgr. In this case, h is equal to 0, so potential energy is equal to 0. Therefore, total energy is equal to 5 by 2 times mgr. 5 by 2 times mgr. Kinetic energy at the horizontal position M or N, that is equal to half m into Vm square. Vm square is equal to 3 times gr. That is, therefore, that is equal to, kinetic energy is equal to 3 by 2 times mgr. Potential energy at horizontal position is mg into r. Since h is equal to r, therefore potential energy at the horizontal position is mgr. So, taking the sum, the total energy is equal to 5 by 2 times mgr. 5 by 2 times mgr. From these expressions, we concludes that, see the total energy at every position, and that is constant, that is same. That means in vertical circular motion, total energy is always conserved. Always conserved. Always conserved. Remember this. Always conserved. And kinetic energy can be converted into potential energy when it goes from lowest point to highest. Lowest point la kinetic energy maximum hai. Potential energy becomes 0. Potential energy becomes 0. And at highest positions, the potential energy is maximum. Potential energy is maximum. That is 2 times mgr. But the potential energy is 0 at the lowest position. Lowest position. That means kinetic energy loses can be converted into potential energy. Kinetic energy can be converted into potential energy. Remember this. Okay. Total energy is always constant. In next slides, we can find out the relation between tension at the lowest point and at the highest point H in vertical circular motion. Here, Tp is the tension produced at any string. We have already seen. From this, the tension at the lowest position also we can see TL is equal to M upon R into bracket VL square plus GR. Also, we can find out the tension at the highest point, that is equal to M upon R into bracket VH square upon GR. These expressions can be already seen in earlier slides. Therefore, the tension at the difference between the tension at lowest position and highest positions becomes equal to TL minus TH is equal to M upon R. TL is equal to M upon R into bracket VL square minus GR minus M upon R. M upon R in both the cases are same. So common it M upon R into bracket VL square plus GR minus VH square and minus plus GR. Therefore, this is the expression for TL minus TH. From this expression, TL minus TH is equal to M upon R into bracket VL square minus VH square and GR plus GR, that is 2 times GR. But we already seen that VL square minus VH square is equal to 4 times GR. Therefore, tension at lowest position minus tension at highest positions is equal to 6 times mg. 6 times mg. This is always constant. Remember this thing. Tension at lowest positions is greater than 6 times mg, greater than tension at the highest point by 6 times mg. By 6 times mg. Tension at lowest position is greater than the tension at the highest position by 6 times mg. 6 times mg ने ते जास्त असेल हे लक्षात ठेवा. Now, case second, if the mass tied to a rigid rod instead of flexible weightless string, we assume a rigid rod which have negligible mass, and when the mass tied to such a rigid rod and whirled in a vertical circular motion about the other end, at that time what will be the speed? What will be the speed at a different positions that can be found out. In this case, the rod is rigid, so it cannot be slackened like a string. String सारखं तो slack होणार नाही, तो tightच राहील. Hence, when a body is at uppermost point edge, tension is not necessary. टेन्शनची गरजच नाही तिथं. टेन्शनची गरज नाही, कारण तो स्लॅकन होत नाही म्हणजे तो जो मास आहे ते मास खाली येणार नाही डायरेक्टली, म्हणजे ते लूज होणार नाही. ड्यू टू द स्पीड and due to the inertia, it goes to complete the vertical circular motion. Even though the tension becomes 0 or less or 0 जरी झालं तरी काही हरकत नाही, कारण तो रिजिड रॉड असल्यामुळे तो स्लॅकन होत नाही, तो लूज होणार नाही. त्या ठिकाणी तो बॉल किंवा तो मास असेल ते मास डायरेक्ट खाली येणार नाही, म्हणून टेन्शनची गरज नाही. Thus, zero speed is possible at point H. H point ला, that means highest point ला 0 जरी स्पीड राहिला तरी काही हरकत नाही, तरी तो इनर्शियामुळे, ड्यू टू इट्स इनर्शिया, इट गोज forward and complete the vertical circular motion. So, the conditions for that purpose, the speed at the highest point becomes 0. Speed at highest point becomes 0. Speed त्या ठिकाणी 0 पाहिजे. That is the minimum speed required at the highest point when the mass tied to a point mass tied to a rigid rod. Rigid rod. So the velocity at the lowest position can be found out by using these expressions. We know that VL square minus VH square is equal to 4 times GR. But here VH is equal to 0. Therefore VH square is equal to 0. Therefore VL square minus VH square is equal to 4 times GR is VL square is equal to 4 times GR, and therefore VL is equal to square root of 4 times GR, and therefore VL is equal to 2 times square root of GR. This is the minimum speed required at the lowest positions, in this case when the mass tied to a rigid rod. Now the speed or velocity at the horizontal positions, m or n, that becomes VL square minus VM square is equal to 2 times GR. 2 times GR. How that can be possible? That can be explained here by using the relations VL square minus VP square is equal to 2 times GH, is equal to 2 times GH. 2 times GH. That is the equations we have already studied. We have already studied in the earlier slides. That can be here. VL square minus VP square is equal to 2 times GH. And instead of P point, we write M point. And when the point P to M, L to M, at that time height is equal to R, that is radius. That means H is equal to R. Therefore, VL square minus VP square, VM square is equal to 2 times GR. And from this equations, VM is equal to VM square is equal to VL square minus 2 times GR. But VL square is equal to 4 times GR. Therefore, VM square is equal to 4 times GR minus 2 times GR, that is equal to 2 times GR, and therefore VM is equal to square root of 2 times GR. These are the expressions for the speed at highest positions, at lowest positions, and at horizontal positions in the case when the point mass tied to a rigid rod which have massless or negligible mass. Remember this. In this case, we considered speed becomes 0. Speed becomes 0. And in the case of string, we considered tension becomes 0. Tension becomes 0 at the highest point. This is the difference between these two cases. But the relation between the tension at lowest point L and highest point H remains as it is. That is, tension at lowest position minus tension at highest positions is always equal to 6 times mg. Here is also that conditions satisfied. Here also these conditions can be satisfied by the rod. By replace the string by rod, this conditions is satisfied. This is the vertical circular motions which is under the gravity. Another examples of the vertical circular motions we have already seen in circus. That is this sphere of death. Here we observed such a spherical body, hollow spherical body. In that hollow spherical body, two-wheeler riders can be in motions. Sometimes it can be moved. That riders can move horizontal circular motions, inclined circular motions, or completely vertical circular motions. This is the sphere of death. We have already seen in circus. Inside these hollow spheres, the riders starts with small horizontal circular motions. First, the rider moves along this horizontal circular motion, and now then increase the speed and changes its circular orbit, changes its circular orbits inclinedly, and then vertical circular motion. Perform vertical circular motion. Its dynamics is same. Its dynamic is same. When the rider comes to the top points, here the rider is at the top points. Even the rider is at the top point that cannot fall down. Why? Due to the centrifugal force. Due to the centrifugal force. Centripetal force acts toward the center, and at the same time centrifugal force can be experienced by it. And when both are the same, then that cannot be loose from its. That cannot be loose from its. This motion is just like as the mass tied to a string. Tied to a string. Tied to a string. स्ट्रिंग मध्ये आपण टेन्शन कन्सिडर करतोय. स्ट्रिंग मध्ये काय कन्सिडर करतोय? टेन्शन कन्सिडर करतोय. इथं नॉर्मल रिएक्शन्स असतात. इथं काय असतं? नॉर्मल रिएक्शन्स असते. इथं बघा, इथं दाखवलेलं आहे. इथं खाली वेट आणि वरती नॉर्मल रिएक्शन. वरती काय आहे? नॉर्मल रिएक्शन. या ठिकाणी नॉर्मल रिएक्शन्स इन्स्टेड ऑफ टेन्शन, इथं तर आपण समजा हे घेतलं असतं तर इथं टेन्शन खालच्या दिशेने आलं असतं. तसं इथं नॉर्मल रिएक्शन सुद्धा रोड सरफेस इथं आहे, आणि रोड सरफेसला परपेंडिक्युलर नॉर्मल रिएक्शन्स अलॉंग दिस डायरेक्शन्स, अलॉंग दिस directions. Weight is also along this direction. That means N plus mg is equal to centrifugal force, that is mv square upon r. And as the normal reaction becomes zero, that is this. That means tension, we have considered tension becomes zero. Tension becomes zero. Here we consider normal reaction becomes zero at the top points. At the top points. At the top points. Top points ला आपण normal reaction zero consider करायचं असतं. This is the difference in the sphere of death and mass tied to one of end of the string. All the expressions in the mass tied to a string, one end of the string, that expressions and the expressions for sphere of death are same. Are same. Remember these things. Instead of tension, we replace normal reactions. We replace normal reactions only. The expressions will remain same as earlier studied in the articles, mass tied to one end of this thing. Another vertical circular motions, another example of the vertical circular motion, when we goes through the overbreeze, and overbreeze is like a convex surface. Here it is seen that the two-wheeler, here this two-wheeler goes through this convex breeze, like this. At that time, what is the maximum speed required at the top point or the highest point of this circular motion? This is also circular motion, vertical circular motion. This is also vertical circular motions. That is the examples. That is the example. During the motion of vehicle over the convex breeze, and reaches at the top, points like this. At that time, forces acting on the vehicles are, its vehicles are its weight acting vertically downward directions, and the normal reactions. The resultant force acting on this vehicle toward the center, that is mg minus n. This is the resultant force acting toward the center, and that resultant force provides the necessary centripetal force. If v is the speed of this vehicle at the top points, then mv square upon r is the centripetal force. centripetal force. This is the expressions to find out the speed required at this top points in the convex bridge, on the convex bridge. Now, from this expressions, it is clear that m is the mass of the car or vehicle, that is constants for the given car. G is the acceleration due to gravity, that never be changed since the top point cannot be changed. This is the this distance is remain same, so the acceleration due to gravity is same. Radius for the given road surface is same. So speed is depends upon the normal reaction. So speed is depends upon the normal reactions. As the normal reaction decreases, speed becomes increases. That means as speed increases, normal reaction decreases. Normal reaction decreases. Normal reaction decreases. Thus, the normal reaction indicates the contact between the vehicle and the road surface. Vehicle and road surface. Road surface. That's it. Thus, vehicle has maximum speed when it just maintaining the contact with the road surface. Beyond that speed, when the normal reactions become zero, at that time there will be no contacts between the road surface and the vehicles. If the normal reaction becomes zero, when the normal reaction becomes zero, at that time just contact the tires of the vehicles with the road surface. But when the speed is greater than that maximum speed, at that time the vehicles cannot be in contact with the road surface. If this is considered road surface and this is the vehicle, this is the road surface and vehicle is moves along such a type, if the speed is larger than this maximum speed required here, at that time the vehicle moves verticals upwards and lose the contacts with the road surface. That jumps, vehicle can be jumps. So the vehicle safely moves without losing contact. So the normal reaction becomes considered zero. And when the normal reaction becomes zero, at that time the vehicle just maintaining the contact with the road surface. So the normal reaction becomes zero, just contacts city, and at that time the maximum speed required becomes mg is equal to mv max square upon r, and therefore v max square is equal to gr. Here m and m get cancelled. Therefore v max square is equal to gr, and therefore v max is equal to, taking square root on both sides of this equation, so we get v max is equal to square root of gr. This is the maximum speed required at the convex road surface, at the top of the convex road surface. These are the examples of the vertical circle motions. In practice, observe these vertical circle motions. Thank you. Now here we will stop here. If you like this video, subscribe to my YouTube channels RD Patil, and after that click on the bell icon buttons for the notifications of the other videos also. Thank you again.